Hey, this is chapter 13.1, and we're going to be using trigonometry with right triangles. So we have our 6 trig values, which are sine, cosine, tangent, cosecant, secant, and cotangent. And they talk about the relationships between the sides and angles of triangles. So this is based on this triangle here, in which we have an acute angle called the theta angle. Theta is the Greek letter theta, and we have our hypotenuse and our 2 legs. And so sine of theta would be opposite over hypotenuse. So we take the opposite leg's value and divide it by the hypotenuse value. So our cosine theta is adjacent over hypotenuse. So each of these has a different value of, or a different ratio of one leg to another, or the hypotenuse. So how we remember what each of our trig functions are is we have SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The reciprocals of each of these, so the reciprocal of sine, or 1 over sine theta, is cosecant theta, which is just that, the reciprocal. So we have hypotenuse over opposite instead of opposite over hypotenuse. We have each of these for cosine and tangent as well. We have secant theta and cotangent theta. So in a problem, we will be told to evaluate the 6 trigonometric functions of angle theta. So we can see that we have our angle theta here, and we have our 2 legs, which are labeled with the value of 5 and the value of 12. First, we need to solve for what our hypotenuse value is. So we can use the Pythagorean theorem to get 13. Once we know 13, we can think of SOHCAHTOA for our trigonometric functions. So to find sine, we know that this is the opposite over hypotenuse. So the opposite of theta is 12 over the hypotenuse, which is 13. Cosine of theta is adjacent over hypotenuse. Therefore, we have 5 over 13. Tan theta is opposite over adjacent, therefore we have 12 over 13. 12 over 5, excuse me. And now we have the reciprocals, so we can either multiply each of these by the reciprocal, or we can just flip them. So we have 13 and 12, 13 over 5, and 5 over 12. We're just taking each of our base trigonometric values and flipping them. Next, we're told to find an unknown length of a right triangle. So we know that our theta angle is 30 at this point, and our 2 values are that of our adjacent leg and that of the hypotenuse. So which trig function has the adjacent and hypotenuse? So we think of SOHCAHTOA. Cosine has adjacent and hypotenuse. So the cosine of 30 equals adjacent, which is x, over 8, which is the hypotenuse. Multiply both sides by 8. And x equals 8 cosine 30. And you can plug this into your calculator to find an exact value if the book asks for it. So finally, in our section, we're going to be talking about radian measure, and we're going to be comparing this to degree measure. So a radian is a value that we use to measure circle values similar to degrees, actually, like I said. And there are 2 pi radians in a full circle. Therefore, 360, which is a full circle, is 2 pi radians. And therefore, 180 degrees equals just 1 pi radian. So when we're going from degrees to radians, we multiply by, so we have our degree multiplied by pi radians over 180 degrees. This is our conversion factor. And similarly with radians to degrees, we multiply our radians by 180 over pi radians.